Hello everyone, in this video we're going to cover object-oriented JavaScript, and this video is made so you can start in any place, see the timestamps for the part of the video that you're interested in, and open the folder for that part of the video. So let's go ahead and get the code. So I'm going to go open github.com/truthseekers/ I think it's JavaScript OOP. Okay, and then here's all the code. You can download a zip folder or git clone it. So I'm gonna grab that line of code, or the SSH, and I'm going to cd into my desktop and git clone and then paste that string. Okay, then we got that folder, so cd into it and open up the project folder. So once we have the project downloaded to wherever you want it, we can pull it open in a text editor, and we'll have a bunch of files and folders, and then we'll want to start dragging these into the web browser. So we're going to start with one, and we're going to work all the way up, but we're going to just do this one at a time. So we're going to start at the one intro. So I'm going to drag that in, hit enter, and I'm always going to have the dev tools open so we can talk about how the code works. Okay, so let's open up folder one. So the first thing is in the script.js, we can just create a very simple object. And objects are created using these little curly brackets. And so what we're doing here is we're creating an empty object and storing it in the const of u1. So now we can access this object and add and edit properties on that object by using the dot notation. So u1.name equals Bobby. So we're adding a property name with the value of Bobby on u1. And then we're adding a value of age, which is equal to the number of 14. And then we can add functions too. So we can do u1.incrementAge equals a function that increases u1's age by 1. So because this is a function, we can add parentheses to this to call it. So you can also add existing functions to objects. So for example, we have this print info object that prints out the u1's name and age with some string text. And then down here we add the print info function onto the u1 object as a print info property. But we're not adding it with the parentheses because that would call the function immediately. We want to wait and allow the function to be called when we want it to. So that's why we store it without the parentheses. So anyway, that is the user1. Let's go ahead and print that. I'm going to just do a console.log u1, and I forgot to do that earlier, so you probably won't have to write that, but let's save that, and then we will refresh, and we get u1 name is Bobby, age is 14, increment age is a function, and print info is a function as well. So now and these are functions, so we can just call them, and we'll do that later on, but this is our first simple object. User2 or u2 is very similar, only this time we're not creating an empty object and then adding properties to it. We're creating an object that already has object properties inside of it. So we've already got name Cindy, age, and then an increment age function which increments the age by 1. And then this time we're storing print info 2, which is the same thing as print info, but just to demonstrate. So we're storing print info 2 with the print info as the print info 2 key, and then we're also using the fancy ES6 syntax for test prop, which kind of like makes the test prop the key and the value because it's got the same name. So this is equivalent to this line above, only it's test prop instead of print info. And then now we can just access these properties. So u2 has a print info2 function on it, which calls this function here. And then increment age, we'll increment the age by 1. So we call that twice. So the age goes from 49 to 51. And then we print the print info function again to see how the name is changed. And then we can call the U2 test prop just to verify that that test prop works. So let's go ahead and take a look at the code output. And so we get, my name is Cindy, 49 years old, and then we increment our age twice, and then it becomes 51. We see that the test prop works, and we see that the user one's name works. And so this is a very simple object usage in JavaScript. So I'm going to go ahead and close out one intro and open up this prototype thing folder. So, oh, and I have to shrink it down. So I'm going to open up this one now. To what is prototype? Okay, so let's open up a script file. We'll demonstrate why prototype is helpful soon, but a quick summary is that prototype prevents us from having to have the same function in our app for every instance of an object. If we had 1,000,000 zombies, we'd have to have 1,000,000 walk functions, one for each zombie. Instead, we want to be able to store all our reusable functions in one place and look up to them. So that's what we are doing with this prototype thing. So we're going to make an object. This is going to be called zombie functions, and now we have two functions. We have make noise and then walk. So these are both functions are stored in zombie functions, and then anytime we want to make an object or an instance with these functions, then we can just create them in a way that they look up to this zombie functions. So we do that with this object.create. So we have two objects here, Z1 and Z2. They're both going to represent zombies, and we're going to create them with zombie functions as the kind of like thing that helped create them. So we can give them their own custom properties, but we can also use these functions now. So we have Z1 object.create with zombie functions. And then now we have the ability to call the make noise function with anything that was created with the zombie functions. So z2.makeNoise should work. And then we also are again able to make custom properties on these objects as well. So Z1, we have their own, it has its own name. And then we're going to print out the entire Z2 object just to see like what it has available to it. So let's take a look. We'll refresh, and we get Bob. So z1.name is Bob, and then we're printing out z1's.name, so we have that. And then we're going to print out the entire Z2 object. And so if you look here, we get name Cindy, and that's all we get. We don't have anything else other than this prototype thing. So if we look here, we're calling make noise on the Z2, and it works. We have this make noise function that is running. And the reason that works is because we have this prototype here. So this object, when it doesn't see make noise on it, it's going to look up to the prototype. And so if we click here, we see that we do actually have make noise and walk, because this object looks up to these. And it looks up to these because we created the object with this .create, and we passed in zombie functions. So it looks up to all of these and has access to them. So that's why this make noise works. And then you'll also notice that this object itself has a prototype. So here we have another prototype. So it's kind of like a chain that it will continue looking up the chain until it can't anymore. And so this here is the parent object that all objects look up to by default. So has own property, is prototype of, toString. All of these functions are available at the very top level. And so that's something that JavaScript provides us. And so we can actually demonstrate the usage of some of these in the code in our files here. So after z2.makeNoise, we have z1, we're logging z1.hasOwnProperty name and hasOwnProperty test. So the way that this property works, again, this is given to us by JavaScript. It says, does this object have a property with the name of test name? And does it have the property with the name of test? And then it returns a Boolean. So does z1 have a name property? Yes, it does. Does it have a test property? I don't see one. So it's going to print out true and false. So let's take a look. We get true and false. And then the next thing that we have is demonstrating object.create with no parent function. So if we use null, then this object is not going to look up to anything. So we have a working object just to demonstrate that the same thing works when you just create a plain old object. So we have a working object which is empty, and then we create a .prop property on it with the value of la la la. And so we say, does working object have a property named prop? Yes, it does. And so we print out true here. Yes, it does have a .prop property. But then if we try it on broken object, which we've created to not look up to anything, then we no longer have access to this hasOwn property. And that's why we get an uncaught type error. Broken obj.hasOwn property is not a function because it's not looking up to the parent object that JavaScript provides us that has this hasOwn property. Because again, this working object doesn't actually have a hasOwn property prop. It looks up to it. So if we were to log out working obj, it would have this .prototype on it. And then that's where it would find this hasOwn property. But we don't have that on working obj or on unbroken obj because we're creating with null to not look up to anything. And let's actually print these out real quick just to kind of actually see this in action. So console.log working obj, console.log broken obj, save, and we'll refresh. Okay, so we can see this working obj. It has a prototype object thing that we can look up to hasOwn property. But then if we look up at this broken obj, it has nothing. So because again, we've done the create with null on the broken obj. So that is everything in this file. So I'm going to close this out and then open up. I'm not going to do 3 because this is just an exercise. You can feel free to take a look at it, but I'm going to go ahead and go to this 4. What is functions versus objects? So I'm going to hit enter and we'll start in this code now. Not the index, I want the script. The main point I wanted to get across with this file is that functions are also objects. And you can put properties on these functions as properties. You can even put functions on functions as properties if you wanted to. So we have this animal function here. And now we're going to add a .prop to the animal function with the value of heyo. And then console.log, if we console log animal function, we can, and then animal function.prop, we can see, this information in the console. So let's give that a try. Refresh, and we can see here we just get the function. So it's kind of interesting how it doesn't actually show the whole object. It just shows the function and the body of the function. But if you print out .prop, animal function .prop, we actually do get the property. So it still exists even though it's not showing up when we print out just the function. You'll also notice that animal function has a .prototype property on it that we can access and log. And then the next thing is we'll just actually call the function to see it running. So if we look here, we get this weird constructor object here, the dot prototype, and then we are calling the function, which says I am a function and an object. So I am a function and an object, and we'll cover this a little bit more very, very shortly. So the next thing is we have an animal object. So notice the difference, like this is an animal function and this is an animal object. So if I console log the animal object here on line 25, the animal object here exists and it looks up to a prototype. But if I log out the animal objects dot prototype, it's undefined. So objects do not have a dot prototype on them, but they do have a prototype that they look up to. So animal functions have a dot prototype property, but animal objects do not. So the prototype that this animal function, the prototype that this animal object is looking up to is actually a dot prototype property on a function. So objects look up to prototypes that are on functions. So this animal function has a prototype property that objects will look up to. So if we use this animal function to create this animal object, then this animal object would look up to this animal function's prototype. I know that's very confusing. So let's keep going and it'll make more sense by the time we get to the end of the file. So the next thing that we do is we add a prop2 property with this string on the animal function's prototype. And so when you add something to a prototype of a function, it is available like throughout the entire app. So even though we are console logging the animal prototype up here before the prototype has actually been assigned the prop2 property, it's actually still available. Sorry, not the animal prototype, but we're the animal functions prototype. So when you assign something to the animal functions prototype property, it will be available like throughout the entire app. So it's going to be available up here when we console log animal function.prop, even though we added it way down here. And I want to actually see the animal function.prototype. So this should be like line 11. We should be able to see this string here is accessible. So let's look for line 11. Okay, line 11 here. I click this down and we get this sum function here. It looks like we've added, and then this prop2, and then the constructor and the prototype for the rest of the objects. So we'll talk about this constructor in a moment. So anyway, we have access to this like throughout the entire app, the stuff that is on the animal functions.prototype. Okay, so the next thing is we want to make sure that when we're creating something, like using this object.create, that you create this object based off of not a function. You don't want to base it off of a function. You want to base it off of a prototype. So a function's prototype is fine. So if you were to do animal function.prototype, that would be good. But you don't want to assign it like to do the .create with a function inside. You technically can, but it's not the way that the JavaScript class-based system was designed. It was designed specifically to utilize the .prototype on functions to like look up, to have like the lookup chain on. So you can do this, but you don't want to. So if we have an example, if we look at this example here of us doing this, we can see the data is available. So let's start looking at line 36. So 36 is right here. So it says function, and that's because a function is technically a kind of object in JavaScript, which is confusing, but we don't need to really get to that. But this function itself has a prototype, and this prototype has the hey yo on it. And if we look at it, I think we defined it up here. So we do have access to those, but again, it's just not the way that that JavaScript has been designed. So, and then we also should get access to prop2, which is, bro, this is ridiculous. So here we go. Bro, this is ridiculous. And this is actually on animal functions.prototype. So we've got the dot prototype of the function. So it just gets kind of confusing. So when we try to do a console log for animal2.prop, this is actually going to work. And that's because the thing that goes inside this create is supposed to be the quote unquote object that is looked up to. And so animal function is a function, but it's also an object that we've added a dot prop to. So we added the dot prop to the animal function up here. So we've created this object to look up to this animal function. So when we're looking up to this animal function, we're saying, hey, does this animal function have a property called dot prop? And we see that it does. Animal function dot prop is equal to hey yo. So when we try to log it, it works. So 37, we get hey yo. But keep in mind that before it looks up to the animal function, it checks on animal2 itself to see if a dot prop exists. So if there was a dot prop on animal2, this would overwrite the one in animal function. But we'll get to that a bit later. When we try to access animal2.prop2, we don't find it because the dot prop2 is stored on the animal functions dot prototype. And I'm not entirely sure why when the prop2 is requested that they don't look in the animal functions prototype or dot prototype. I think it's just not how dot prototype was intended to be used. So anyways, prop2 is not available on the animal2 object. To get access to the prop2, we need to base the object off the animal function dot prototype like we do with animal3. So when we log out animal3, when we log out the animal3.prop, we're not going to be able to access it because the dot prop is not on the animal function dot prototype. It's only on the animal function. So let's look at dot prop. Dot prop is on animal function. However, we are going to get access to prop2 because we are again basing this animal3 object off of the animal function dot prototype. This animal3 is going to look up to the animal function dot prototype, which is where prop2 is stored. So that's why we are not going to get access to dot prop, and we will get access to prop2. So let's look at line 43 and 44 in our terminal. 43 and 44. So undefined for prop 43, and then we get our string on prop2, which is right here. And this is how you want to do it. You want to have your objects look up to a dot prototype object on a function, not the function itself, but on the prototype. And then I don't think there's anything new to look at on the actual function itself. So we just get the prop2 as something that we can look up to. And then I think the rest of the stuff below isn't really anything new. So like I said earlier, we can store properties on functions, including a function as a property. So we have a func on func, which is the name of a property, and we're storing a function inside of it. So we can actually access that, and then this animal function dot prototype we can store a function on the prototype. So that means that the animal3 should have access to this func on prototype. So let's take a look at the animal3 object and see if it does. So animal3 prototype func on prototype. So we do have access to this function, and then we're able to call the function, this func on func, and I think that's line 56. 56, where is that? Why is that not being called? Oh, I think it's because it's created here on line 48. So it would be I am func on func, I am func on func. So that's called, and then we can also call the func on prototype. So I am func on prototype, and you can call it in these different ways as well. And then the last thing is, it's totally fine to make an object that looks up to another object. And that's actually what I've been saying. So like you want to do it on, you want to make an object look up to a function's prototype, which is itself an object. And so this animal, I'm hoping it's an object, we'll scroll up, but that's what you want to do. You want to have this, like this lookup object, like the thing that it's looking up to, be an object, not a function. So A1, let's see if animal here is an object. Should be. Yep, animal is this object. And so now we have access to is alive on A1 because is alive is a property of animal. And then A1 or increase health should also be a property of animal, because we don't have those on A1. So the program first looks on A1, it doesn't see it, and so then it looks up to this object here. And if it doesn't find it on that, like a has own property or whatever, if it didn't have it on an animal, it would look up to the final parent object. And you can have as many objects as you want, like in that chain. But anyway, is alive and increase health should be on animal because it's not on A1. Otherwise, it would return undefined. So let's see animal is alive and increase health. Okay, and so that's the end of 4 prototype functions versus objects. Let's close that out. And I'm not going to open up 4.1. It's just kind of an exercise that I didn't really complete. So you can feel free to take a look at it if you want. I don't think there's much there. So 4.5. we're going to use as an example. And so we haven't covered classes yet, but I did want to show you like why you want to use the prototype and not just stick it on some function. It's because the class system in JavaScript is designed to use prototype. So again, we haven't covered this yet. We'll get to this soon in these later sections. And I need to get rid of this comment. But basically what we're doing here is we are creating an object, level 1, and this object has a property and it has a function on it. So this is essentially a way to create an object. This isn't an object itself, but it's like an object creator, I guess you'd call it. And then eventually we have another class, level 2, that extends level 1. So this is essentially what we've been doing. This would be like, level 2 object.create, and then base it off of level 1. So level 2 has access to all of the functions and properties the level 1 has, plus its own. So we have these prop2 and level 2 func. And then another object down here, or another class, this level 3 class extends level 2. So level 3 has access to level 2 and level 1. And so we can call this level 3 function and access prop1, prop2, and prop3. And prop3 is only defined on level 3. But we're able to access prop2 and prop1 because when you make an object from the level 3 class, it will first look on the level 3. If it doesn't find anything, it will look up to the object level 2. So it'll look up and it'll have access to these. If it still doesn't find it, then it'll look up to level 1. So when we call level 3 func on an object that was created by this level 3 class, then we can access all of these. So let's just see it in practice. So we have a new const level 3 or L3 equals a new level 3. This creates a L3 object, and then we call the level 3 func on the L3 object, and it works. So if let's pull this up and then pull this index.html page on here, we get level 3 calling prop 1, 2, and 3, prop 1, prop 2, prop 3. And this is basically just calling or accessing the properties. So prop 1, prop 2, prop 3, we get access to them. And anyway, the point that I was trying to make is that in that last section is that you want to access, or you want to use the dot prototype, not the actual function itself. So this is correct and this is incorrect. And we can see that the good injection works and the bad injection doesn't, because on this good injection, we're injecting this function. Like what we're trying to do here is we're saying, okay, let's add this function to the level 2 class. And so when you use the prototype, it works. But when you do not use the prototype, it doesn't work. And this will make a lot more sense when we get to the classes section. So let's just see this good injection and bad injection. Oh, and I'm doing it on level 3 because this level 3 object once again has access to the level to everything on level 2 and everything on level 1 because it extends them, it looks up to them. So when we call L3.goodInjection, we get I am a good injection, do it this way. But when we try to add a function directly onto the class without using the prototype, it's not going to work. So when we try to call bad injection, we get uncaught type error. Bad injection is not a function because this bad injection function never made it onto the level 2.prototype, which is how this class-based system in JavaScript is used to look up the chain of objects. So long story short, use the .prototype. Okay, so that was it for 4.5. Let's finally start to get into this. So 5, what is this? I'm gonna drag the index into the browser, and here we go. Well, let's look at the script. So the basic summary of this entire section is this refers to the left side of the dot. And so we can see that illustrated here with this test function. So we do a function, test function, and then we just call test function. And inside the test function, we're requesting this, but there is no left-hand side of the dot. So in this situation, this refers to the window because there is no left-hand side of the dot. So let's take a look, and we get this in test function window. But let's try it again with this myObj object. So this object has an age property and an increase age function, and inside of this function we do this.age++. And so we're increasing the age by 1, but again we have to see where this is actually being called at. So when we log this in increase age, we're logging this here in this increase age function. Let's find a place where we're actually using the increase age. So the first thing, we just log the whole object on line 25. But after that, we do myObj dot increase age. So inside of this increase age, we're using this. What does this refer to? It refers to the left-hand side of the dot. So which dot? It's this dot right here, the dot where the function is being called. So this refers to the left-hand side of the dot. The left-hand side of the dot is myObj. So this should be myObj. So, and then inside of this function, we're calling this. So again, this should reference myObj because it's the left-hand side of the dot. So let's take a look at it. Okay, this in increase age 42, and the increase age function. So it was 41, but it increased by 1, so now it's 42. And then it also has an increase age function, and here's our increase age function. So left-hand side of the dot, that's what this is referring to. And then after that, we're just logging the age property of my obj, which should be, I think, 42 at this point. So yep, 42 on, what line is that? 27 right here, and then we're just logging the obj again. That we don't need to really see that. So now let's try calling this, or we'll set this get age property. We're going to make a new property on my obj, and we're going to set it to this function print age from outside. And so print age from outside is this function we created here, and it also references this, well, this dot age, the age property of whatever this is. So let's call this print age from outside on my obj. And again, we're doing that because we're able to set this to the get age on my obj, and then we call that function. So what we're really doing when we're calling this is we're calling print age from outside. So again, what does this refer to? The left-hand side of the dot. What's the left-hand side of the dot in this situation? My obj. So on this print age from outside, we should get this my obj again, which has the age property and the increase age. So let's take a look. We're going to look for the print age from outside. Print age from outside's age of 42. And again, that is the age of this object. So the next thing is to look at this inner obj. So we take the my obj and we set a new property called inner obj equal to a new object. And this object has an age of 54. And it also has a print inner age function, which is really just print age from outside, the same old function that we had earlier. So now when we call my obj dot inner obj dot print inner age, which is actually print age from outside with this, what is this referring to? The left-hand side of the dot. What is the left-hand side of the dot in this situation? It's inner obj. So this should now have an age of 54, and it should have a print inner age property. So let's look at that. Print inner age is outside age of 54. And we're actually not printing the whole object, so we're not going to see the print inner age property, but we do see this age. So we see that the left-hand side of the dot in this, or the this in this situation, is inner obj. And then I changed the log here. It was incorrect because we're not using classes, and I added another comment down here. But let's take a look at how this works in this kind of situation here. So you may have seen something like this before, where there's just kind of like it's seemingly magic here. So what's happening? What we're doing here is we are using this, and because we use the new keyword, we'll talk about the new keyword later, but the new keyword uses this to automatically create an object and store the values inside of that object and then return it. So doing this here, when you call the new keyword, is equivalent to doing something like this. Call a car function with 2 parameters, and then we make a new object with storing those parameters onto the object and then returning the object. So this and this are pretty much identical. And so that's what this is doing. It's just referencing this internal object that gets automatically created. So hopefully that makes sense. And that is it for this section. Let's move on to arrow functions. Okay, we have our browser, and now we have our file, and I'm going to close everything out except the arrow functions. Okay, so the first thing that we do is we create a global arrow const, and then we create a myObj, which is just got a bunch of functions in it. And then the first thing we do is console log myobj.age. We increase the age, and then we console log myobj.age again. So if we look at the dot increase age on my obj, it uses the regular old this with a normal function. So this refers to my obj because the left-hand side of the dot when calling increase age is my obj. So this should work as we discussed in the last section. So 41, this in increase age is the whole object, and then now it's 42. So an arrow function is going to work a little differently. So the next thing we do is we have running my obj.arrow test. So we're going to try to run the arrow test function. So we do that here. Let's look at the arrow test function. And this is basically the same exact thing, only it doesn't have this.age++. So this in arrow function, and then we get to see what this is. So let's take a look. So this in arrow function is the window object. So why is this the window object? And so I think I may have refined this a little later in this file, but you can ask yourself, what is the this of the thing where the arrow function was created in? So where was the arrow function created? This arrow test function was created in my obj. So what is my obj's this? Well, so my obj has a this of the window. All the functions and properties inside of it have a this of my obj, but my obj itself has a this of window. So that is why this is window. And you'll notice that later on you'll notice that we don't have to have a left-hand side of the dot with arrow test or with arrow functions. So anyway, this is the window with arrow test. So I think we move on to arrow test 2 next. And so we have a log that just says running my obj.arrow test 2, and then we actually run the function. So the first thing that happens when we run this function is it just says arrow test 2's this is my obj, so an arrow function in here should have it to this be my obj. So it's just a log to kind of like get your bearings of where you're at. So again, but what it's saying is the arrow test 2, it's a regular function. And so when you call arrow test 2, you're calling it on my obj. Just like we did here, my obj.arrow test 2. Arrow test 2's this is my obj. So this function, this arrow function here, when it gets created, it says, okay, what is the this of the thing that I was created in? Well, this was created in arrow test 2, which has a this of my obj. So when we see this in arrow test 2's this, it's going to be my obj. So running my obj.arrow test 2, arrow test 2's this my obj. This in arrow test 2 is my obj. But you'll also notice that earlier I said you don't need a left-hand side of the dot. This is the situation here. So this in arrow test 2 has a this of my obj, but there's no left-hand side of the dot. It's just being called, out of the blue. And then just for fun, we call this global arrow function. And so what is the this of the global arrow? Well, what is the this of the thing where global arrow was created? Global arrow was created here in the global scope. So global arrow's this should be window. So let's global arrow this. Let's look for that in the browser. Using global arrow using global arrow in arrow test 2, global arrow this is window. And here we go. So even though global arrow function is called inside of arrow test 2, the global arrows this is still window, because the global arrows function was created out here in the global scope, and the this of where it was created is the window. So hopefully that makes sense. The next thing is this arrow test3. So we have a console log of running arrow test3, and then we call arrow test3. So let's find that in the browser. Running arrow test3. Here we go. So arrow test3 on my obj is just us setting a property of arrow test3 with the value of the global arrow. So I guess what I was trying to do here is to see if there's any way that I can get the this in global arrow to be switched over to something else. And it doesn't look like there is a way, at least not that I'm aware of. So setting the global arrow to here to my obj, my obj.arrowTest3 property, and then trying to call arrowTest3, which is really just calling global arrow, we're still going to get the this of a window because global arrow was created in the global scope, and the this of where it was created is window. So let's take a look. So my obj.arrowTest3 would calling that would just be calling global arrow, which is going to say global arrow this. So if we look at global arrow this, we still get the window. So that's it for arrow test3. And then the next step is these lines. And I think at this point, it's just doing what we've already learned about arrow functions, just with the prototype. So basically we have a car model. So we're creating car objects with this car model, and car model is a function. And so functions have a dot prototype on them. And so we're basically just adding a make noise function onto the car model's prototype. So we have this function here, and we have an arrow function inside of the make noise function. And so we're able to say vroom says that this dot make and this dot model. And so we're using the vroom function inside of the make noise. Again, there's no left-hand side of the dot, but it's an arrow function, so that should be okay. Let's see if this dot make and this dot model are actually coming from the right place. And so we can let's take a guess. I'm trying not to read the comments, but where is the arrow function created? It's created in the make noise. What is the this of the make noise? And it actually feels like it's kind of hard to tell what the this of the make noise is until we actually see it being called. So let's look down here. Okay, so we get c1.makeNoise. So the this of the make noise in this case is the c1 object. So vroom should work. Let's take a look. Okay, vroom says the Toyota Venza on line 58. Line 58. So Toyota Venza, this appears to work. And then also in here, in this make noise function, we have vroom2. The difference between vroom2 and vroom is that vroom2 is not an arrow function. So when we use vroom2, we need, in order to get the this.make and the this.model to be something, we need to have a left-hand side of the dot. And we don't here. So vroom2, this.make and this.model is going to be undefined because the window object does not have a .make or a .model property on it. So vroom2 does not work. And we can see that because, or we can see that in our browser. Vroom says the undefined. So that is arrow functions. Okay, and let's take a quick look at the 6.5 arrow functions because there's a little bit of a gotcha. So this one's kind of difficult to follow, and I think that the main thing to look at is to notice that with one variation, we're storing bar as we're calling it. So we're calling bar off of object 2 and storing it in function or fn versus storing the function and in a way that we're able to call it at a later time. So here we're calling it now, here we're calling it at a later time. And then it also returns a function, and then this returns this, and then this returns a function. So it gets kind of crazy. But anyway, what we're going to do is we have an object, obj2. It has a function here, or bar, and then an object name property of obj2. And so we're going to call bar, so obj2.bar, and we're going to return the result of that into fn. So what happens when you call obj2.bar? So obj2.bar creates an arrow function. Let's not worry about what's inside the arrow function. Let's just worry about like the fact that we create this arrow function, and then we return it. So we're returning this function x out from bar. So when we call obj2.bar, we're returning x into fn. So now when we call fn, so fn becomes a function. So this function x here is fn now. So it's a function, and you call a function by adding parentheses onto it. So when we call fn, we are actually calling x. And so what does x do? Well, it logs out this log here, and it logs out this. And so the question is, what is this? So in this situation, when we call bar, it creates the arrow function. So when we call bar on obj2, when we're creating this function, like again with arrow functions, you ask, what is the this of the thing it was created in? So in this situation, bar's this is obj2. So, and the x arrow functions, this is the thing it was created in, and so bar's this is obj2, meaning x, the x function has a this of obj2. So now when we call fn out here, the this of fn should be obj2. And so let's check to make sure that's correct. This is the first, this fn here is the first time that the function, or that anything gets called, and it logs. So we should get, so when we call fn, this should be obj2. Let's see if that's correct. Okay, so here we go. And this is obj2. So obj name, obj2, and then bar of the function. So now let's look at the next example, which is where we're not storing bar as we're calling it, but we're storing the function to be called at a later time. So again, functions get run when you add the parentheses. So we're storing, in this section, we're storing the bar function inside of fn2, not the result of calling bar, which is what we did in fn. So when we store bar in fn2, we still need to call it. So when we call fn2, we're actually calling bar, which then creates the arrow function. So now when we call fn2, we get this x arrow function. So we have to ask ourselves, what is the this of the thing x was created in? So bar is out here now. So what is the this of fn2? Well, it's not obj2 anymore, because you can kind of think of this as like us pulling bar out of obj2 and separating it and putting it into the global scope here, or fn2. So when we're calling bar now, it's out here in the global scope. So this of the arrow function, where it was created, is actually out here now. So bar's this is window, meaning X has a this of window. And so also the other thing to notice is that when we call fn2, fn2 is just bar, which just returns the function. So nothing is going to show up in the browser when we call this. There's only two things here, so we would have a third thing if this showed anything. So anyway, it shows nothing because all we're doing is returning this X function, this X arrow function. So anyway, we call fn2, it creates the X arrow function out here in the global scope, and then if we want to actually use the X function, because it returns a function, we actually have to add another set of parentheses. So this is why we have fn2 with two sets of parentheses, is because the first thing that happens is bar gets called, it returns this arrow function, and then we add a second set of parentheses to call the function that we returned, which is X. And so with the second set of parentheses, we're able to call this X function. So we call this X function here with these two sets of parentheses, and then we get this inside const X, which is inside bar, and now it's window. And again, it's window because the X arrow function was created out here, because bar was kind of detached from obj2 and stored out here in the global scope. So when the X arrow function was created, it was created out here where the this is the window. So pay close attention to where the arrow function's actually being created. So hopefully that is not too confusing, and I hope this makes sense. Okay, we're done with 6.5. Let's close those out and open up 7. So I'm going to drag the index.html into here. Okay, so we get 7, and then I don't know why that opens, but 7 script.js. In this section, we're going to be talking about call and apply. And so we have a human object here with an age property, and then an animal1 object with an age property. And then we have a what is this function that just prints out the this, and it prints out this.age. And then we have an age property, which we'll learn about in just a second, or we'll learn about why it's there in just a second. So let's call the what is this function, and it's going to print out, like when it's all by itself, it's just going to print out the window object. So let's take a look, and we get this, what is this? So this, the window, and then this.age is 2000, which is interesting, and that comes from this age property that's stored on the global. And so I don't actually know why it's doing that and why that doesn't work inside of like function scope, but I don't really think that it's that important. I've never had to like deal with anything like that, so I'm not going to worry about it. Maybe I'll do another video about it in the future if it ever comes up. But the point is that the what is this is referring to the global, the window object. But what we can do is we can call the what is this function with a dot call. So functions have a dot call property that allows you to force the this to be something else. So again, when we call what is this by itself, it's the global, it's the window object. But if we use dot call human, we can actually force the what is this to reference the human object. So here on line 34, when we're calling this, we're actually saying that this is going to be the human object this time. And so the human object has an age of 15, and it has some other like broken arrow increment, increment age, and stuff like that, and a weight of 200. So when we call what is this, we should get the human. So this and what is this, we get the human, all the functions and properties that object has, and we get the this.age of 15. So that's how call works. And then we can also run a function like increment age. So like increment age adds 1 to the existing age. But this increment age function exists on the human object, not on the animal object. But we're actually able to borrow the increment age from the human and use it on the animal one. So let's give that a try. So animal one's age is 4. And if we, okay, so console log animal one, we're going to look at that. And so animal one had an age of 4, and then after running the call and apply, let's see what animal one's age is. Animal one is age of 6. So we can see that this call and apply worked because it was 4, and now it's 6. So again, we can borrow a function or property from another object and force the this to reference something else with call and apply. And then we can see how call and apply works with arrow functions too. So this has arrow increment age. If we try to use call on it, and we're gonna try to force it to have this of animal one, we'll see if it works. So let's take a look at the has arrow increment age. So in the human has arrow increment age, it's actually just a regular function, but it has an arrow function inside of it. And so again, going back to our arrow function section, what is the this of the thing it was created in? Well, what is the this of has arrow increment age? It would normally be human, but we are forcing it to be animal one. So, or we're calling it to be animal one. So the this is actually animal one in this add one, and then we call it with the this being animal one. And so let's take a look and see if that actually worked. So we've tried to use the has arrow increment age and in reference to the animal one object, and then we have a log of the animal one object after calling has arrow increment age. So let's see if the age has increased. And it has. So it went from 6 to 7. So this does work with call. And so now let's try it with the broken arrow increment .call. So this time we're actually using call on an arrow function. And so call, bind, and apply don't work when they're directly on arrow functions. So let's take a look at broken arrow increment, see what it is. So broken arrow increment is an arrow function. This has arrow increment age is a normal function with an arrow function inside. But this broken arrow increment is an arrow function. And so call, bind, and apply do not work on arrow functions. So when we try to console log this in arrow increment age, let's give it a try, or let's see what we have. So broken arrow increment .call animal one, and then we log animal one after trying to increase the age with the broken arrow increment. Let's take a look at what we get in the logs. So this in arrow increment age is the window object. And so because we didn't get the correct this, the animal one's age did not increase. So arrow functions will not work when you try to use a .call or apply on them or bind. So that's another aspect of arrow functions. And I need to fix the log in the broken arrow increment. I apologize for this because this in arrow increment age is not actually correct. It should be this in broken arrow increment. So I'm going to change that. Broken arrow increment, save. So now let's go back down to that add function that we made at the end. And I added this log off screen because I feel like it's good to see this. So anyway, we have an add function with two parameters, and we can pass in them and then add all of them together. And so when you call add by itself, it may not work as you want it to, because the this.age and this.weight is, it depends on, what you do with the this. But anyway, this may not be reliable. So let's look at what the this is when you just call it like, with add and the two parameters like normal. So I'm going to actually refresh. Okay, so we get this in add is the window, and the window has an age, but I don't think it has a weight. I'm pretty sure I didn't put a weight on the window object. So that's why, like, it's undefined. So you can't add like a number plus an undefined thing. That doesn't make any sense. So we end up with this not a number when we try to do this. So yeah, this age would work, num1 and num2 works, but this .weight screws everything up. So we get not a number here. But let's see if we can call. So we can run this add function with the .call to force the human object to be the this. And then you can also add parameters afterwards. And there's two ways to do it. So basically what we're doing is we're saying run the add function with 10 and 20 as the parameters, but make human the this. And so now let's look at that. So now the second time we call it, this and add is the human. And the human has a weight, age and a weight. So we're able to add everything together and we're able to spit out an actual number. And then we can do it with apply to, which is basically the same thing, only the parameters are wrapped in like an array. So you get an array of parameters. So this would be the first parameter, this one would be the second parameter, etc. So apply works basically the same as call, just with different syntax. So and again, we're applying this to have the human as the this. So that is how call and apply work with when you have parameters in the function. So anyway, that is call and apply. All right, so let's look at the next section, which is bind. So I'm going to shrink that down and then pull in the index.html from the 8 folder. And we've got some bind stuff to look at now. So if I open up the script file, we have this print this function that basically just prints this with some text in it. And so normally the this, like if you don't have a left-hand side of the dot, it's going to be the window. But you can bind a this to be something else. So for example, if we call print this, but we bind it to some other object, we can force the print this to have a this of whatever object we pass in. So print this.bind is making this object here be the this of print this. So we store this all in print this bound. So when we run a console log print this bound, this is actually just a function. It's just print this with this object here as the this. So that's why we see like a function body here when we hit console log. So this from print this is just the print this function. So we can actually run this function by adding parentheses at the end of it. So print this bound, but instead of getting the this of the window, we're going to get this object here because we've bound it. So print this bound, let's see what that is. So this from print this, we get obj1 as the obj name and the prop. So here we go, yeah hi and the obj1 obj name property. So that's how .bind works. But once something has been bound, like once because the print this bound has already been bound. So we cannot bind something on something that's already been bound. So this example is not going to work. Bound2 equals print this bound dot bind. We're not able to rebind something. So if we console log bound2 and then run bound2, which is print this bound with a failed bind, we're still going to get the yeah hi object as the this. So bound to yeah hi. So again, you cannot bind something after it's already been bound. And you can do this. So you can reuse the print this though, because if we do print this dot bind, that's like just using this regular old print this. So this hasn't been bound. This is like a new, it's almost like a new instance of print this. So you can do something like that. So hopefully you can see the difference between these two. So bound 3 works. If we log bound 3, obj name bound 3, I work though. And then the arrow functions don't work. You cannot bind on arrow functions. So down here we have an arrow print this const, which is the same thing as print this, only it's an arrow function. So arrow print this here, and we try to bind with the arrow print this. So const arrow bound 1. We're trying to bind it to an object with the object name of arrow bound 1 and a prop. So when we try to log arrow bound 1, it will call this arrow print this, and it's trying to make this object here the this, but it's not going to work because it's an arrow function. So this from arrow print this is a window. So it doesn't work. And it really doesn't matter how we spin it. We can't really just get the arrow functions to work. So I've tried to have a test object and set the arrow print this to this arrow property, but this isn't going to work because the arrow print this is still created in the global scope, and the this of the thing it's created in is the window. Same with this nested arrow. If you stick it in this test prop and you try to call it, the arrow print this is still created out here in the global scope, where the this of the thing it was created in is the window. So none of these are able to get the bind to work on an arrow function. So that is pretty much arrow functions and this dot bind. So I think we are done with number 8 folder. Let's move on to 9. And I'm actually going to do this out of order. I apologize for the numbering, but let's do 10 first because I think it's just going to be easier. So we'll do 10 new first. And so we're going to open up that script.js folder or file, and we have a function. So zombie know this with a weapon and a speed. And then we're going to try to create a zombie from this function. And notice there's no new. I don't know why I said no this. I should say no new. Anyway, we have zombie know this. So we call this function with parameters of teeth and 4. And so we have the zombie's weapon is going to be his teeth, and then, or her teeth, and then the parameter 4 is going to be speed. And the first thing we do in this function is log the this. So let's see what the this is. So we're calling this function, but there's no left-hand side of the dot. And it's kind of interesting because we're like assigning it the value of returning this function into zombie know this one, like a const. But anyway, there's no left-hand side of the dot, so this is going to end up being window. So let's see, this zombie know this window. So that isn't quite what we want. So we're going to set the Windows weapon to be weapon, and then the Windows speed to be speed, and the Windows health. So that's not exactly what we were trying to do. So in this situation, we would need to manually return the object. We need to manually create the object and then store the weapon, the speed, and the health inside that object and return it. So this is not what we want. We can use the new keyword to make it a little bit easier. So down here, we're actually making a zombie function with a weapon and speed. We're doing the same thing that we did up here, but the Oh, and then we're adding a decrease health with the prototype. But after we make this zombie function, we can make new objects based off of this zombie function. It will auto create an object. It'll set the this to that object, and then it'll assign the values that we pass in, and then it will auto return it. So it does a little bit of stuff for us. Kind of some code magic here. So anyway, let's create an object with that new zombie, but we have to use the new keyword in order for it to do all that stuff for us. So we try to make a new zombie. We store it in Z1 with the weapon of teeth and the speed of 400. And so we log the Z1 object to see what we get. And we also try the decrease health to see if that works. So let's take a look. We get Z1, the speed is 400, the health is 99. So the health is by default 100, so we've decreased the health by 1, and we still have, teeth in the 400. So this apparently works. Like, this is what we wanted to do. And this is basically what the new keyword does. It just auto returns an object for us and it helps us create the object easier. And because we have this prototype here, we can actually access this decrease health function that we've added to the prototype. And so all objects that are using this new zombie creator will have access to everything on the zombie's prototype. So anyway, that is the Z1 new zombie. That's how new keywords work. Let's take a look at this bad zombie. And so the difference between the good zombie and the bad zombie is that, like, they both work and they're both fine, but this decrease health function is directly stored on this zombie. So every time you create a new bad zombie, we have an additional decrease health function. And that's going to be a huge waste of space if you have a million bad zombies. So I've decreased the health by 1 on the bad zombie, and we can see that it still works. But let's take a look in the log at the difference between Z2 and Z1. So if we look at Z2, we have a decrease health function on the bad zombie. But in the Z1, we don't. So in the zombie function, in order to get to the decrease health, we have to look up to the prototype. And so the difference here is the bad zombie is making its own decrease health function every time for every zombie. But with the good zombie, it's not making a new decrease health function. They're all, bar every single zombie that is made from the good zombie, is kind of like using a community decrease health function. So they're all using the same function. So this function is only written once in the computer memory. And so it's taking up less space. So that's why we want to make sure that we use the prototype properly, so we're not wasting a ton of space in the computer or in the application. So hopefully that makes sense. You want to use the prototype. And so I kind of glossed over this, but that because of the way the prototype works and how you don't want to like duplicate the functions, that means that here, like this is the good way to do this without using classes, where we do like new zombie. But if we're going to be using the function like this, then if we need to add something that's more than just like static information, so like right here, this is all, none of these are functions. So if we want to add a function to this object creator, then we need to use the prototype. So that's why we did it this way. So anytime you have functions, when you're doing something like this, you want to add the functions onto the prototype. So anyway, that is the end of this new tutorial. Let's take a look at classes. So we'll open up 11, drag the index into the browser, and then we will open up the script file. So the new keyword does some magic for us, and then adding a class does even more magic for us. So what we're doing here is we're creating a class of user, and then we'll revisit this in a moment. And then we're using this class to create a new object and store that in the U1 const. And so when we pass in parameters to the user class, we pass these first to the constructor. So Sammy and 27 get passed in as name and credits here. And then this should look familiar. This is what the new keyword basically does for us. So we're auto creating and auto returning an object with the name and the credits from the parameters that we passed in. So then we get this object, and then this is the equivalent of us doing the prototype. So in the new one, in the new file, we couldn't just add the functions in the zombie class. We had to do like zombie.prototype.decreaseHealth. Well, that's what we're doing in this section here. So use credits, we're adding this function and this function to the prototype of this user. So that means this user is actually a function. So, or this user class is actually a function. And so again, this use credit and show credits are on the prototype. They're functions on the prototype of the user, and then they have access to the object, the left-hand side of the dot. So when we run u1.showCredits, we're basically logging out the this.name of the left-hand side of the dot, which is u1. And so u1 was created. So we have the u1's name is Sammy. So this.name is Sammy, and then has 27 credits. And then there's nothing really new about the use credits function, but if we try to log the u1.hasOwn property, so again, this hasOwn property is on like the parent object, and so it's not directly on the u1, but it looks up to the prototype of the user. If it doesn't find it there, then it looks up to the parent of that. So, or what it looks up to next item in the chain, which is the parent object, which has this hasOwn property. So this is again just using the lookup chain. We've already really covered that. And then if we log the user.prototype, we should see the use credits and the show credits. So true, because we do have the credits property. So the u1 has a credits property, and then we should have use credits and show credits, and then the parent object has own property. So that is an intro to classes. And so we're done with this 11 folder. So let's close this out, and then I'm going to open up the 12. I'm not really going to talk about it too much. So this is basically just like what we did with that level 1, level 2, level 3 area. We're creating a human, then we're creating a superhuman, and then a super duper human. And instead of using the classes, we're just using the object.create. So the superhuman has all the functions that the human has, because we're basing this function off of the human, or this object. And then we're making a super duper human that is created based off of the superhuman. So the super duper human gets all the functions that the superhuman gets and all the functions that the human gets. And so we can call super duper human, or we can store that in this object here, and then we can basically just use any of these functions. So that's all. I think I just wanted to have a quick review on this before we talk about the final thing, which is the class inheritance. So let's go ahead and open up 13. I'm going to drag index.html into this, or into the browser, and we'll click the script. And so now we've got a user, an admin user. Oh, okay. I thought I would have done another level, but oh well. So we have two classes, and then one inherits from another. So let's talk about it. And sorry, it doesn't inherit, it looks up to. So anyway, we have a class, user, and then we're going to try to create a new user, and we're going to store it in u1. So this is the same old user we had, user Sammy with 27 credits. And so we have this u1.showCredits. So this is the same old stuff from last time. Sammy has 27 credits. And then I logged out the whole user object just to kind of see it. And then we can see the lookup, show credits, use credits. So then after that, we've already talked about how it has the has own property and all the other like parent object functionality. And then the user.prototype. So nothing special there. It's all the same stuff. So the admin user extends the user. So let's just go down here and start with the creation of an object based off the admin user. So we are passing in parameters to the admin user. So 1, 2, 3. So admin name, admin credits, and bio. So the admin user's first parameter is Lois, so that would go to the admin name. The second parameter is 23, which would go to admin credits. And then the third parameter is the I like granola bars, which is the bio. So because this extends the user, what we're doing is we have to use the super to pass in this information to the regular user. Because this admin user object is it's an extension. It looks up to the user. So we have to pass information to the user as well. And we do that with super. And so this super passes the information to the regular user object, which only has 2 parameters. So which ones are which? So the regular user takes a name and credits. So the name and credits that were passed into the admin user, we just need to pass those into the regular user. So again, we do that with super. So the admin name gets passed into super and the admin credits gets passed into super, which passes the admin name and admin credits, Lois and 23, into the constructor of user. So that means we go into here and we make this object have a name of Lois and the credits of 23. So we get that object and then we add these functions to the prototype of the object, and then we spit this object out and then we pass it to the admin user, which then creates its own properties. So now we have that, we have this object, now we create the bio property, which is I like granola bars. It says admin user has extra functionality. And then from there, we add more functions to the admin user's prototype. So the admin user has its own prototype, and then the user has its own prototype. So the admin user has extra features, so like remove or fix. Oops. And actually, I don't think this function is doing anything, so I'm going to get rid of it. Okay, so we have these extra functions that only the admin user can use. So then finally, we spit the object out to AU1, or admin user 1. So now we can use these functions. So if I try to call increase user credits and pass it the parameters that it takes, so the user and their credits, we can use this function on the admin user. This function in particular takes the user to add the credits to and then the number of credits to add. So we're adding 4 credits to user 1. So we can see that that works because Tammy initially has 27 credits, and then now she has, or Sammy, and now she has 31 credits. So we see that that function worked, and then we're using the show credits function on the user 1, and then the show credits on the admin user 1. And then the last thing is just to print the whole object so we can see everything that we've done so far. So let's just see that we have 2 lookups at this point. So admin user will first look up to increase user credits, or the admin user's prototype, which has the increase user credits and the show bio. And then if it doesn't find whatever it's looking for in here, then it will look up to the next prototype, which is the regular user. So this one has show credits and use credits. So that's basically how the lookup chain works. And then if we were to do something like has own property, it wouldn't find it on the admin user or the admin user's prototype or the user's prototype. So it would finally look up to the parent object, which has the has own property. So that's how the lookup chain works. And then let's do one more section. I actually don't really use this stuff that much, but there are private and static methods as well. So let's take a quick look at those. So I'm going to pull 14's index into the web browser and then open up the script here. So this example is very similar to what we had before. The only difference is that we have a public method, which is literally just a regular old method that we've been using. And then there's a use private method, which calls a method with a hash sign in front of it. And then there's an actual method with the hash sign in front of it that is private. So this function cannot be called outside of this class. So it can only be called by another function or piece of code inside of the class itself. So, and then we have a static method with the static keyword in front of it. And this cannot be called on an instance of the object. It can only be called on the class itself or the function. So we'll demonstrate that soon. So then we create the user, just like last time, we store it in the U1 object. We have an extended user. And let's try so the public method is just a regular method. We don't need to look at that. But this u1.usePrivate method is going to call the private method. So usePrivate method. UsePrivate method. It says I'm using the private method, and then there's a this.private method, which gets called inside of here. And so by running that line below, we should get using private method, and then I can only be used from inside the class, see use private method. So let's see if we get that in our code. So it says using private method, I can only be used from inside the class, see use private method. So that's how the private method works. Let's try to do that just like calling it directly. So private method, and I'm going to try it here. I'm going to comment this out. So I'll try it like this. u1.private method. u1.private method is not a function. It doesn't work. Let's try it with a pound sign in front of it. Just get the syntax error, it looks like. Okay, syntax error, private field, private method must be declared in an enclosing class. So that is the private method. So we can't do that. We have to use it inside of the class itself. And then the static method is interesting. It's not called on a user object, it's called on the entire class itself. So the object creator is where you're going to call the static method. So we use this user to create the U1 and the U2 and all those. But if we want to call the static method, we have to call it on the user, not the user instance, but the entire class. So that is pretty much how the static method works. And we can try it here. Uncaught error, u1.static method is not a function. But if we save it again and refresh, we get it. I cannot be called on an instance of the objects I create. So that is static methods. And so we're pretty much done with this file. I wanted to show you one more thing. I made a new folder off screen to compare the class-based method of extending objects versus the manual prototype method that we learned at the beginning. So let's pull the index.html into the web browser, hit enter, and then close out the index. We don't want that. We want the script file. So we're going to pull open the script file, and we're going to look at the difference between the two. So, or how to do the same thing that we just did in classes with the prototype. So we have a constructor, we have a describe myself. We tried to use a private method, but it doesn't look like you can actually use private methods outside of classes. So we won't be able to do that with prototypes, but you can uncomment these and feel free to try them yourself to see how they attempted to work at least. And then we have a static function, which is again only called on the class itself, not the actual instance of the class. And so here's the alternative way to do this without classes. So we would have the human object, or the human function, like this would be the human function or the human object creator. And it would take in the same parameters, name, favorite food, favorite drink, name, favorite food, favorite drink. And then we would call new on it. So again, like when we call the new human alternate, it auto generates an empty object. It connects this to that object, and then it returns the object. That's exactly what this constructor function does here in the class. And so once that's done, we also need to have the functions. So we covered earlier the prototype, and we also showed you how you can add functions onto functions via properties. Well, that's what the static function is doing. So this human alternate is just a function. So right here, it's just a function. So we're adding some static function property on the human alternate, which is itself a function. So we're adding this function here onto this human alternate, and then we're using this inside of this function. And so that's how the static function works. And if I don't want to cover like that again, you can check out the earlier part of the video if you want a refresher on that. But the next part is the prototype. So the describe myself function is a function that is called on the actual object, the instance of the object. And so this describe myself would go on the prototype, just how like the describe myself here goes inside the class but outside of the constructor. So then we have this describe myself function, which automatically gets put inside of this human function's prototype. And so let's try to just log them out and see how they're both very similar, almost identical. So we have a h2 for the human alternate, and let's create, okay, we also have a new human here as well. So we should be able to look at these and they should both be pretty much identical. So let's take a look. Here's the human class, has the arms, the favorite drink, the favorite food, the legs, the name, and then here's the alternate. We have arms, favorite drink, favorite food, legs, and name. And then the functions on the prototype, if we look in here, we get describe myself. And then for the actual static function, that's not in the prototype. It's only available when you call it directly from the human alternate. So like human alternate dot some static function, or human dot some static function. So that's on the function itself. So if we open this constructor, we get a some static function. And then down here, if we open our constructor, we get some static function. So these two are pretty much equivalent. And again, we can't do the private methods outside of classes, or at least I'm not aware of how to do it. So that's one way to do it with the class, and then the manual way to do it with the human alternate. So feel free to play around with that, and that is pretty much classes versus the manual prototyping way. And at this point, I'm not even going to bother with the 9 this in classes, because we've covered literally everything that there is to learn in that folder already by looking at these other folders. So you can feel free to take a look at it if you want. But that is object-oriented programming, this, and arrow functions, and the prototype chain in JavaScript. Thank you for watching the video. Please subscribe to our channel and click the bell to be notified when we release new tutorials. Also be sure to like the video and leave a comment to let us know what you think. Lastly, check out the link or links in the description. We usually create a blog post to go with the tutorial, and we might have a newsletter or course or something to check out as well. Have a good day, and I'll see you next time.